So they can ask you that a typical question can come like this. Expand 1 plus x all to the power 5 and find the value of 1.2 to the power 5. Okay. This is a typical question that may come. So with this one, you can use Pascal to do the expansion, which I've already taught you. Or you can use this formula. And always, I would advise that this formula shouldn't depart from you, because this formula is very simple. This is the combination aspects and it is for the coefficients. This one will give you the A term and that will give you the A part of the term, and this one will give you the B part of the term. So this one is the most easiest. So with this, you can say 1 plus x to the power 5. So you can attribute 1 and x by A and B. So you say let A equals 1 and x equals B. Then you use it to do the expansion. So this is the formula for each term. This formula is for each term. And you know that I said that R starts from 0. And it will end at the nth term, which is 5. So it is this way. So 5, which is n, combination 0, a to the power 5 minus 0, b to the power 0. That's the first term. So you do the same thing for the next term. 5 combination 1, a to the power 5 minus 1, b to the power 1. 5 combination 2, a to the power 5 minus 2, b to the power 2. There's a third term, so 5 combination 3, a to the power 5 minus 3, b to the power 3. Then you do the same for the the 5th and 6th term. So 5 combination 4, a to the power 5 minus 4, b to the power 4. The 6th term becomes 5 combination 5, a 5 minus 5, b to the power 5. Do you understand? So now you start. So 5 combination 0 is 1. So 5 combination 0, 1, a to the power 5 minus 0 is definitely 5. So a will be to the power 5. So it becomes a to the power 5. B combination 0 is 1. So a to the power 5 times 1 is still 5, a to the power 5. Plus 5 combination 1, which is
5 combination 1 is 5.
Good, 5. So 5 minus 1 is 4. So a will be to the power 4. Then the b will increase. You see, I said the a takes the first power in the first term. So as the next term comes, the a will reduce by 1, b will increase by 1. So you don't need even a combination, you should know. Okay, so the next term becomes 10, isn't it? 5 combination 2 is 10. So 10 a to the power 3, because a will fall by 1, then the b will be 2. It will increase by 1. I'll show you another trick that will tell you that what you are doing is right. Okay, so the next term 2 becomes 10 a to the power 2, b to the power 3. Then next term 5, isn't it? With 5 combination 4. 5 a to the power 1, b to the power 4. Then 5 combination 5 will give you 1. So a to the power 0, b to the power 5. So let me show you how you get to know that what you are doing is right or wrong. What is the maximum exponent? 5. You should make sure that each term, the total, when you add the sum of their exponents, you get 5. So here a is 5. Okay, so after you are done with the expansion, you compare it with that of the question. So you know that this is a plus b to the power 5. So by comparison, a is 1 and b is x. So you insert the values. 1 to the power 5 plus 5 brackets 1 to the power 4 brackets. So b is x. So wherever you see a, you put 1, and wherever you see b, you put x. So here becomes 10, 1 to the power 2, 1 to the power 3, x to the power 2 plus, then bracket open, 1 to the power 2, x to the power 3, 5, 1, x to the power 4 plus x to the power 5. So that is it. Okay, so when you do it, you get 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the power 4 plus 5x to the power 5. 1. And 5 times 1 is 5. 1 to the power 4 is 1. Wait, 1 to the power any number is 1. That one you should know. So you know that regardless what 1 is raised to the power with, the answer is still 1. That's why I just multiply through. So here is 1. That's it. 1 times 5. 1 times 5 is 5 times x, so 5x. 10 times 1 is 10 times x squared, so 10x squared. 10 times 1 is 10 times x cubed, will give you 10x cubed. 5 times 5 times 1 is still 5. So 5 times x to the power 4 will give you x to the power 4. Then 5. So x to the power 5 will be the last thing. So now that you have this is the expansion. So we are done with the first part of the question. It says expand x to the x. It says expand 1 plus x to the power 5. So now that you are done, you compare this expansion that we are to find, which is 1.2. It says after we are done expanding this, we should find 1.2 to the power 5. To the power 5. So with that, we compare it with this. So by comparison, we know that they are all to the power 5. So therefore, we can split this 1.2 to 1 plus 0.2. You know that 1 plus 0.2 is equal to 1.2. So when you split it, this is the breakdown. So since 1 is here and it is here, we can equate x to 0.2. Therefore, x is equal to 0.2. You know the 5 and 5 are still the same. So therefore, we can say since x is equal to 0.2, then when we come here, wherever we see x, we insert 0.2. So 5 bracket 0.2 plus 10 bracket 0.2 the power 2 plus 10 bracket 0.2 to the power 3 plus 5 0.2 to the power 4 plus 0.2 to the power 5. So when you add all this, you get your final answer. That will be the answer for this. So when you add it, you get what 1.2 to the power 5 has been